Have we been searching for life on Mars the wrong way all along? Could it be that the very experiments designed to find life actually wiped out the evidence we were looking for? Join Vin's Curious Corner as we explore the journey to conquer Mars. Did NASA accidentally destroy evidence of life on Mars? Has following the trail of water become an outdated approach in the search for life? To this day, we haven't found any conclusive evidence to prove that life once existed on Mars. But several decades ago, in the 1970s, we may have come very close. That was when NASA's Viking landers became the first U.S. spacecraft to safely land on the Red Planet and begin exploring its surface. However, according to astrobiologist Dirk Schulze-Makuch from the Technical University of Berlin, a scientific experiment carried out to detect signs of microbial life may have accidentally destroyed the very clues we were looking for. When the Viking landers touched down on Mars in 1976, they were equipped with multiple scientific objectives. One of their key missions was to run a series of biological experiments to test Martian soil for signs of life, essentially, molecular evidence that life had once existed there. To this day, no similar biological experiments have been repeated on Mars. One such experiment involved the gas chromatographed mass spectrometer, GCMS, which detected chlorinated organic compounds. At the time, the results were dismissed as contamination from Earth, possibly from cleaning agents used on the spacecraft, and thus not taken as biological evidence. Today, we know that chlorinated organics do naturally occur on Mars, though whether they are produced by biological or non-biological processes remains uncertain. In recent years, some scientists have speculated that Viking's biological experiments might have been destructive in nature. The GCMS, for example, required soil samples to be heated in order to analyze their chemical composition. But this heating process might have incinerated the very organic compounds we were trying to detect. Other experiments may have caused similar destruction, particularly those designed around Earth-like assumptions. These included thermal pyrolysis and wet chemistry tests, which involved adding liquid water to dry Martian soil to look for evidence of metabolic activity or photosynthesis. Some of these tests did show gas exchange, a possible sign of life, but the results were largely dismissed because scientists at the time assumed that life could only develop and survive in the presence of liquid water, as it does on Earth. More water was assumed to mean more life. But later studies have taught us that life can, in fact, exist in extremely arid environments. And Mars is incredibly dry. If Martian life evolved to survive in such dry conditions, then suddenly introducing water could kill it. As Schulze-Makuch puts it, what happens if you pour water on microbes that are adapted to dryness? Technically, you're giving them what they lack, but in practice, you're drowning them. He compares it to a scenario where aliens find a half-dead human in a desert and say, "Humans need water, let's throw this one into the ocean to save it." But of course, that would just drown the person. Interestingly, some of the dry control experiments, where no water was added, actually showed stronger signs of biological activity than the wet ones. That raises a serious question. Did these experiments detect signs of life that we accidentally dismissed? Clearly, there are still contradictions and unresolved questions here. And they deserve more research and investigation. In 2007, Schulze-Makuch proposed the idea that life on Mars could rely on a hydrogen peroxide water mixture and adaptation that would allow it to survive the planet's harsh, dry, and cold conditions. He and his team noted that the Viking results were surprisingly consistent with this theory. If organisms like these really do exist on Mars, adapted to its extreme dryness, then perhaps we need to rethink NASA's long-standing motto of "follow the water." Instead, we might be better off looking for hygroscopic compounds in salts, materials that absorb moisture from the air and could support microbial life. As Schulze-Makuch says, nearly 50 years after the Viking experiments, it's time to launch a new mission to search for life. Today, we understand much more about Mars' environment than we did back then. Let's join together to push for the next generation of space missions with a broader, more creative, and hopeful vision. Because who knows, just one right step could bring us closer to answering the biggest question of all: are we alone in the universe? If you found this content useful and interesting, don't forget to like, share, and subscribe to the channel to join me on the journey to explore and conquer Mars.